Hey, what's up everybody? I'm here today with a Gamemaker Studio tutorial. Today we're going to be taking a look at multi-threading inside of Gamemaker. So for those of you who have used Gamemaker for a long time, you may already be scoffing at the notion, because Gamemaker is innately single-threaded. However, we're going to bypass that by writing an extension in C++ that will allow us to run code on multiple threads. So before we get started, I need to point out that this is not going to be a simple tutorial. It's definitely for intermediate to advanced coders. Unless you already know C++, then it's still a little bit on the intermediate side. In addition to that, I'm going to link down to a tutorial down below, and I want you to read that and fully understand everything that it has to say before we get started. There's a lot of things that I'm not going to be able to explain nearly as well as the author of that did, and it's going to be used quite a bit inside of this. So I'm going to go ahead and get started. You'll see I already have an empty project here. However, we're not going to start here. We're actually going to start with the C++ code. So I'm going to go ahead and go down. I already have a blank Visual Studio open. In here I'm going to go ahead and click on Win32 project. Alrighty, and you can name this whatever you want. It's going to be the library name that we're going to import. So I'm going to call it threading tutorial. Go ahead and click OK. And when this setup wizard opens, you're going to go ahead and click next and DLL, and go ahead and click finish, and it's going to set some stuff up for you. It takes a few seconds usually. Oh, come on. Alrighty. I still need to update my SDK. So for now, you're having the same problem. You'll be able to tell you that you're having a problem if your external dependencies folders has nothing in it. Go ahead and click on project, go down to the very bottom where it says properties. Here where it says Windows SDK version, I'm going to go ahead and put that to the one before the current one. Oh, come on. And click OK, and that will fix the issue. Probably. You'll be able to tell because it starts to add in some files on the bottom there. So I'm going to wait for that to finish off before we get started. Alrighty. So we can go ahead and get started. First and foremost, we need to include some files. So let's go ahead and do that. We need to include thread, of course. We also are going to want to include chrono, because like I said, this is going to be very similar to a timer. We need to include vector, and we need to include mutex. Alrighty. Next up, we need to define a macro. This is going to be the macro that we use on all the functions that we're going to export to Gamemaker. So I usually just call it GMX or GM export, but you can name that whatever you like. And it needs to be extern C, and then whatever this means. All of this stuff was specified in the tutorial that I linked below. So anyways, that's all you need to do there. Now I'm going to set up some aliases for some ease of use. So one of the things that allows this to work is actually being able to return asynchronous or return values asynchronously from a library. In order to do that, the only way you can do that, I suppose, is to actually return a DS map to Gamemaker. And so setting that up is a little bit funky. First off, we're going to set up the DS map alias, so it's going to be using DS map is equal to int, and then we're going to say, I'm just going to do this for convenience sake. It's going to be using thread is equal to std thread, Let's see, and once again, for convenience's sake, we're going to say milliseconds. Seconds is equal to standard chrono milliseconds. Alrighty. We're going to set up a constant. This is going to be the event type. So it's going to be event underscore other underscore social. And this is equal to 70. Alrighty, so if we go back into Gamemaker real quick, what this means, I'm going to go ahead and create an object in Gamemaker real quick. I'm just going to call it obj threading. If we go into events, so we're going to add an event, going to attempt to add an event, you'll see here there's an asynchronous set of events that you can use. One of them is social. This was added in specifically, well, at least partially, so you can return stuff asynchronously. And so this value, for some reason, is 70. I know there's only one other value that I know for sure, and that's Steam, and Steam would be 69. However, we're going to be using social because it doesn't conflict with anything else, I believe. So let's go back to our file, or to our C++ file. We need to declare some function pointers that will be assigned to later. So the first one is going to be the pointer to the function that will actually allow us to return values. This is going to be GML event perform async, and this is going to take in a DS map and an event type, which, like I said before, will always be social, or 70, I suppose. So it's always going to be this, and we're going to just set it equal to null pointer for now. And as you can tell, it returns void. And now we need one that will return an int. This is going to be our DS map create, so GML underscore DS map create. Let's see, and this is going to take in an int in, and then a variable amount of arguments. However, we're never going to add anything else to this. Okay, and then we're going to add in two functions that will allow us to add things to the DS map. So we're going to say GML DS map add double. This will allow us to add a number to the DS map, and it's going to say DS map, or it's going to take in the DS map. It's going to take in a string for its key, a C string for its key specifically, and it will take in a double as its value. So when you're working with DS maps, the only kind of key that you can add in are C strings. You're not able to add, have a map with numbers as the key, only C strings. So let's go ahead and say GML DS map add a string. Once again, it's going to be very similar to the last function. It's going to take in a DS map, C string for its key, and a C string for its value. Alrighty. So there's a couple of global objects that I'd like to create now. We're going to create a mutex. I'm just going to call this thread key. However, you can name it whatever you like. I just like to call it, I like to end my mutex names in key because I view them as kind of locks, and, well, you use them for locking, and in order to lock something you usually use a key. That's just a personal naming convention. Go ahead and name it whatever you like. And then we're going to create two vectors. If you read the tutorial, then you'll know what this is. One vector is going to keep track of open threads, or of running threads, I suppose. And then we're going to have another one that will keep track. Let's see, this wants to be 30. Of the open slots. So we can add more threads in later. Alrighty, so this is probably one of the most important functions that we need to add in. So this is going to be an exported function. It's going to return a double, and it's called register callbacks. And it's going to take in 3 or 4 char pointers. So we got arg1, arg2, so on and so forth. So it takes in 4 of these. Okay, so what these are actually, these aren't actually C strings or anything. These are going to be function pointers. And we're going to convert each one of these into one of the previously created function pointers. So arg1 aligns to GML event perform async, arg2 dsmap create, so on and so forth. And this is called from Gamemaker as soon as the game starts up automatically, so we'll never call it. And it automatically fills in these with the correct methods in order to create a dsmap and return it asynchronously. So we're going to say GML event, start with this one, is equal to, we need to create the correct cast type. So it's going to return void, and it is a function pointer. And the variables that it takes in are going to be a dsmap and an int. Oh. And we're going to cast that from arg1. Just like that. It seems a little complicated, especially if you've never worked with this before, but it really is simpler than it might seem. So we got one that's going to take in an int, and it's a function pointer, and it's going to take in an int or a dsmap, and an ellipses. Go ahead, and that's going to be argument 2. Okay, 2 more. Gmail dsmap add double is equal to a bool pointer, and it's going to take in a dsmap. That's not how you spell map. A C string and a double. And it's going to be casted from arg3, and one more. This one's going to allow us to add strings into our dsmap. Oh, I forgot to put this like that. There we go. So it takes in a dsmap, takes in a string, and then another string. And this is going to be arg4. There we go. And then it just needs to return 0. So the reason that it's set up like this is because Gamemaker can only pass in C strings and doubles. And because C strings are actually pointers, this is the best way to pass in a function pointer from Gamemaker, at least as far as I can tell. In addition to that, I remember reading somewhere recently that back before C89, that void pointers didn't exist, which is what would probably be used currently for a function pointer. And back then they used char pointers for this exact reason. So it's kind of a callback to that way of doing things. But anyways, that's all you need to do there. This will allow us to actually use these methods to interact with Gamemaker. Real quick, we're going to actually create a wrapper function for the dsmap create. So it's just going to be dsmap create. And that's going to return a dsmap. And the reason that we're going to do this is because this will always have to have exclusively 0 passed into it in order for this to work. I don't really know why, but that's just what it said on some documentation. It was a blog post from a while ago. I'll try and find a link to it, and I'll put that in the description down below so you can kind of look at it. But yeah, that's just how it goes, I suppose. Alrighty, so now we're actually going to get into the meat of this program here. So we're going to create a function that's actually going to be run on the threads. And I'm just going to call it void return double. Alrighty, it's going to take in a time value that's going to be the milliseconds that we're going to wait before returning. It's going to take in a type, which I'll explain more later. It's going to take in a value. This is going to be the return value. It's going to take in a handle. It's not actually going to be like a pointer to anything. It's going to be the index that this thread is inside of this vector. Alrighty, so we're going to convert the time value to a double because that's the type needed to create, or sorry, we're going to convert the time to a long because that's the time that you need. That's the type that you need in order to create a milliseconds object. So we're going to say this thread, and we're going to say sleep for milliseconds, and inside of here we're going to instantiate the milliseconds with the time value that we just created. So that's going to cause the thread that this function is running on to sleep for the specified amount of time in milliseconds. Once that's over, we are going to perform the Gamemaker event. So let's go ahead and do that now. I'm going to say dsMap. Oh, that's not the right one. So dsMap map is equal to dsMap create. Alrighty, so that gives us the map that we're going to use to add values to. We're going to say gml we're going to add 3 doubles to it. So first one, we're going to say map. The key is going to be type, and we're going to add in type. I'm going to go ahead and just copy this line and add it 2 more times. The second one, we're going to add in a value, and of course it's going to be value. And of course the last one is just going to be handle, and we're going to pass in the handle. Because int is a smaller type than handle, or sorry, is a smaller type than double, this should be able to convert without any loss, even though in the compiler it will give you a warning. And then after that we're just going to say gml event perform async. And it's going to be, once again, it's going to be event other social. Unless, yeah, there we go. For some reason it wasn't showing up. And actually, right here, I'm going to lock on the mutex around it. You're supposed to use a wrapper function for this. I believe it would be like std lock regard, and it's going to be, it would take in mutex. No? Mutex? And then it would take in our mutex, so thread key dot out, and then something like this. So that's probably what you're supposed to do. Oh, no. No. Okay, honestly, I don't 100% know how to use this. I'm just showing you what's actually the best form. So if you're going to be using this, I would suggest figuring that out. For my case, I'm going to go ahead and lock and unlock the mutex manually. What the lock guard does is as soon as that variable goes out of scope, it automatically unlocks the mutex. That will prevent deadlocks from happening in most cases, or at least it will help prevent deadlocks by programmer error. However, I'm going to go ahead and throw caution to the wind and lock and unlock the mutexes manually. So, like I said, if you're going to be using this for yourself, this is not the correct way of doing things. However, it's the way I'm going to do them, which is very silly. So there we go. That's going to be the function that we're going to call on our threads. So now we actually need to be able to instantiate a thread. So let's go ahead and do that. This is going to be called from Gamemaker. It's going to return a double because they have to have a return value. And we're going to call it, let's call it thread create. Because this is going to be following kind of a similar to a task paradigm, similar to the tasks objects inside of the C# language. In Gamemaker, I'm probably going to call these functions like task initialize and stuff like that, but from in here, because we're going to be using threads, we'll call them threads. So this is going to be thread create. It takes in the time, the type, and the value. Alrighty, so in here, this is actually going to return the handle, just like this will also return the thread handle. Once again, the handle is going to be the thread's position inside of this vector. So we're going to have this variable here. That's going to be what we return. So at the very end, we're going to say return index. And in between here, we actually need to put a lock. So we're going to say thread key dot lock. And then, so we don't forget, I'm going to unlock it already. Thread key unlock. And our code is going to go in between the locks. So this is going to be almost exactly like it was inside of the tutorial. If open slots.empty, that's not empty. Then we're going to say index is equal to threads dot size. We're just going to add on a new thread to the vector. So we're going to say threads.pushback. And you can see that this is actually a vector of thread pointers because we're going to add the thread on by using the new statement or keyword. So new thread. It's going to take in this function, which is return double. And then after that, you specify the arguments that will be passed into it, which is going to be time, type, value, and index. Index being the thread handle that we just found right here. And that is all if there's no open slots. And if there are open slots, it's not that much different. We're going to say index is equal to open slots dot back. We're going to pop the back off. And then we'll assign a thread to that index that we just retrieved. So it's going to say threads at index is equal to new thread with the same parameters as before. So return double, time, type, value, and index. Okay, and that is all. It unlocks our key and then returns the index to Gamemaker. So you can save it and for further use if you want to. And this would be probably the biggest further use right here. This will allow you to stop a thread from returning anything to Gamemaker. And we're going to say gmex. So this is going to be thread underscore, I'm going to call it kill. Essentially all it's going to do is it's going to detach the thread from the main process, which for some reason, I believe, stops the thread. This may not actually be how it works, but I believe this stops the thread from executing, or at least from returning this map. So we're going to say, we're going to lock our key. So thread key dot lock. And then so we don't forget, go ahead and say thread key dot unlock. And then after that, it's going to just return a 1, which is just a random, I mean, it just needs to return something. In Gamemaker, that's supposed to be true. So, I mean, might as well do that. So we're going to say if threads dot size is greater than index, and threads index does not equal null. Okay, once again, this is extremely similar to the tutorial, but we need to check if that thread is joinable. So, if the thread is joinable, which basically means that it hasn't completed yet and it hasn't been detached. So if it's joinable, we're going to go ahead and detach it. Let's see, detach. Otherwise, it will actually need to be joined, which will be done later. So we're going to detach it, then we're going to delete it from memory if we can. I'm not 100% sure how well this works. I think this makes it so as soon as the thread finishes processing, it will delete itself, though I could be wrong. It may already do that by itself. This is just to be safe. It may also just delete the pointer from memory, which once again would be not that bad. Then we're going to set that index to null, and then we're going to push that index back to open slots so it can be used later. And that is all we need to do for this. So this will make it, like I said, so the thread will no longer execute. This is useful for a couple of reasons. The first one is when the game finishes, we're going to detach all of the threads currently running. That may not be 100% necessary, but I believe that it might be, which is good enough for me to do it. And also, if you just want to kill a thread while it's running, this is useful. But probably the biggest one is when you restart the game, all the threads will continue to execute and they'll still return their values. So this will actually cause it so those threads will no longer return their values to you, I believe. So the last one we're going to do is it's going to be, once again, this is going to be something that you call from Gamemaker. And I'm just going to call this thread free, because this is going to free all of the memory associated with the thread after it's finished. Okay, so it takes in the thread index again. We're once again going to lock using our key, thread key dot lock, and once again, so we don't forget, go ahead and unlock it already. Thread key dot unlock, right there. Alrighty, and the reason that we need to lock on these two functions is so the vector doesn't get changed while we're trying to manipulate it at all. That would cause some serious issues for sure. So now we can go ahead and say threads. It's going to be this line again, so I'm going to go ahead and, in fact, I'm actually going to just copy the whole thing because it's going to be almost exactly the same in hindsight. The only difference here is instead of calling detach, we're actually going to call join. Now, you have to be extremely careful when you call this function, because if you call it before a thread is actually finished, it will block the calling thread, so that will be the thread from Gamemaker, until the thread is finished. And then it will delete the thread. However, I believe that this will be fine. I mean, as long as you're careful and you know what you're doing, this is 100% fine to use. So that is actually all we need from the C++ side of things. I'm going to go ahead and build it, and then we can go ahead and jump into Gamemaker. Alrighty, so it succeeded. We can go into Gamemaker, and we are going to create the extension. So to do that, we go ahead and click Create Extension. I'm just going to call this threading. Go ahead and click Create. We're going to add in our library now. Let's see, what did I call this one? Threading tutorial. Alrighty, we're going to go ahead and add in our functions. Once again, first and foremost, the most important one is register callbacks. This has to be added in exactly like this, otherwise it will not work. At least for the Gamemaker name. I'm not sure if the external name has to be the same. However, for certainty's sake, I'm going to go ahead and add it in. For the help, I'm going to go ahead and say do not use in all caps because you should never call this yourself. The type is going to be a C declaration, and the return type is going to be double. Go ahead and add 4 arguments. They should default to string, which is exactly what it needs to be, and go ahead and click OK. Now we can add in our other functions. So let's see, we called it, we got thread create, thread kill, and thread free. Go ahead and go back into here. We're going to call this task init, which is actually going to be thread create. And then here it's going to be task init. It's going to take in some milliseconds. It's going to take in a task type, and it's going to take in a return value. Alrighty, it's also going to return a double, and it's going to be that declaration type. So we're going to go ahead and add in 3 arguments this time. We need to change them all to double, which can be a little bit finicky and annoying, but go ahead. Once you're finished, go ahead and click OK. Go ahead and click add another function. This one we're going to say we're going to call task join, and on here this was thread free. I'm going to go ahead and add this one on first because it will be called far more often than the other one. This is going to go ahead and take in a task ID, and this only has 1 argument, just a double. It returns a double. And 1 more, add function. This is going to be task kill. This is going to be, let's see, was it just thread detach? No, we called it thread kill. Thread kill. So task kill is going to take in a task ID, and it's going to go. Once again, this is going to have to be a double value. Oh, click OK there. And that's all you need for the extension. Let's go ahead and go back into our threading object. We're going to add a create event, and in here, we're just going to go ahead and say task init. I'm going to just do 1000 milliseconds. Task type for now I'm going to say is 0. And the return type I'm going to say is 42, the answer to life. Okay, now I'm going to go ahead and add in a social event. Oh, here we go. And I'm just going to read the values from our async load. So we're going to say, first off, I'm going to say that we received it. So this is just going to be a quick little test to see if we received anything. Received. Okay, we're going to say var type is equal to async load. I'm going to use the accessor for this map, and it's going to be type. Var value is equal to this value. And the most important one to retrieve is the handle. So var handle is equal to async load. Oh, by the way, this async load is a special DS map that's sent to any of the asynchronous functions. This is going to be what actually holds the data for the async function. So for this one, it's going to be whatever you declared. However, some of the other functions, such as the networking event, have special keys that you can use to retrieve the data that Gamemaker has put into the events. So it's going to be type, value, and handle. It's going to be the ones that we created. And so before we do anything with the type and value, at the very end of this function, we're going to go ahead and say task join. And we're going to make sure that that the memory allocated to this task is freed. So we're just going to pass in the handle. This will make it happen automatically. Well, not automatically, we're still doing it, but this makes it so we don't have to handle it any more than this. So for this test, I'm just going to go ahead and say show debug message string type plus, and I'm just going to go ahead and display both of them. It's going to let's see, value. Alrighty, so that's all we need for now. I'm going to go ahead and run it. So this is, yes. Need to add in a room that has this object in it. So this is the most simple thing that you can possibly do with this. I'm going to show two examples of significantly more powerful things to do, however. So going to go ahead and let it run. After 1 second, you'll see we received right here. And our type was 0 and our value was 42. And the game didn't crash, which means that the memory should have been freed properly. So everything is good. And you can see we can still exit the game and everything works as intended. So let's go ahead and add in some things to make this a little bit more powerful. First thing I want to do is I'm going to create an enum. This is going to be what I will usually, this is what I use to pass in as our task type. So the first one I'm going to say is empty script. Alrighty. So down here, now that we have that, I'm going to say task.empty script. I'm going to make sure that this enum initializes to 0. Alrighty. So after that, any other thing that you add to this will be, so let's, for example, let's just say I say filled script. This is just what I call them. You can name it whatever you want. I don't have to say filled script is equal to 1. It will be automatically added to it as it goes down. If you started this off at 1, then, or let's say we started this off at 2, then filled script would automatically be set to 3. But we want it to be set to 0 just for clarity's sake, I suppose. Alright, oh, I didn't want to do that. I actually have no clue how I did that. But we don't want that there. So we're going to say task.empty script, and then for the value, let's create a script real quick. Ser task test. This is just going to say show debug message hello world. Okay, so this is going to take in a script with no parameters. So it's going to be ser task test. So you'll notice I don't put parentheses afterwards. This will allow us to pass in the identifier for the script rather than the result of the script. So let's go back into our social event. We're going to go ahead and get rid of this debug message. And we're going to instead add in a switch statement. And it's going to switch based off of the type. Okay, so right now, the type that matters the most is going to be task.empty script. And this, in here, we're going to say, if we receive this type, oh, I forgot to put case. That's probably useful. In here, we're going to say script execute. This will allow us to execute the script that we passed in, which is actually going to be held in the value. So the index is just going to be value. And I called it empty script because this way we're only going to be able to pass in scripts that take in no arguments. And of course, because it's a switch statement, we can't forget to break. And then we're also going to just add in a default. And it's going to say show debug message. And I'm just going to say received invalid task type. and then I'm going to even show you what the type was. Alrighty. And once again, you need to call break on this, otherwise you'll get some undefined effects, I guess. Okay, so let's go ahead and run this. So as you can see, everything is set up the way you'd want it to. Go ahead and run it. Give it a second to get ready. So there you go. After 1 second, you'll notice that we got a hello world on the bottom. So let's go ahead and do one more thing. This is probably going to be the most complicated part right here. Gonna go ahead. In here, we're going to create a global variable. So it's going to be global.task arguments. Normally, as you can see, I already have, normally I have a macro set up for this type of things. Which you can see I actually already do on this because I was using this to test some stuff earlier, so I called it task arguments. However, for the sake, I'm just going to go ahead and say global.args is equal to no one, and then once again global.args is equal to dsmap, probably dsmap create. And now we're going to create a wrapper script. So we're going to go ahead and say scr task init. So this way we're going to go ahead and say it's going to take in the same parameters as you would pass into this function down here. So scr task init. It's going to take in milliseconds, task type, and a return value. Okay, we're going to go ahead and save our task is equal to task init. It's going to take an argument 0, argument 1, and argument 2. However, we're actually going to pass in one more argument. This is going to be an optional parameter. This is going to say, we're going to say args is equal to no one. This is kind of a Python-y way to show that this is optional, and it's going to tell you what it's going to be defaulted to. So we're going to go ahead and say var args is equal to no one. But if argument count is equal to 4, then we can actually say args is equal to argument 3. Alrighty. So here we're going to do one last thing. We're going to, well, two last things. We're going to say global.args. Oh wait, let's go ahead and do this. ds map add. And the ds map is going to be global.args. The key is going to be the task, and the value is going to be args. And then we're going to return the task ID. There we go. So, this way we can now go ahead, let's say script scr filled script. Let's just go ahead. So this is going to take in a list. Alright. Yeah. So for this one, it's going to be scr filled script. You know what? Let's just call it scr filled. That's a little bit more condensed. And it's going to say, we're just going to call it, say it takes in args. And we're going to say for var I is equal to 0, I is less than 2, ds list, size, argument 0, I plus plus. And in here we're just going to go ahead and print out all of the things that we passed in. Debug. So the way that this works is that whenever you need to pass in arguments to a script, you're going to have to refactor your script to take in a list or an array, or whatever else you want it to. For now, we're just going to make it so it only works with lists. However, you can change it. So you can change it by calling this like list script, and then you can have another one like map script, whatever. We're going to go ahead and I'm just going to go ahead and call it filled script. So we're going to go ahead and say show debug message string, so we can make sure that all of the things will print out correctly. DS list. Oh, actually, you know what? Yeah, DS list. DS list. Find value. Argument 0. And the position is at I. And I need one more parentheses. Alrighty. So this is extremely simple. It's going to take in a set of, or it's going to take in a list that has some arguments, and it's just going to print them out for you. However, you'll notice that if we just go ahead and say like var list is equal to ds list create, we're actually going to have a memory leak. So we're going to go ahead and handle that. But first off, ds list add hello ds list add world. Okay, so we can now say in 1 second we're going to call a filled script, and it's going to take in scr filled. And actually, we need to make sure that we're using the right version of this, so scr task in it. And our args is going to be list, if I spell that correctly. Alrighty, so this will call this function with these arguments after 1 second. However, after, now we actually need to go ahead and add that into here. We can go ahead and say case task dot filled script. Go ahead and say script execute. If I spell script right, I'm so used to the shorthand version that I always use. Value, and then we're going to also say global dot args. Let's see. Also, it's going to take in the value, and then it will break. Alrighty, so this will actually call it correctly. However, after the thing is, oh, I don't actually want this to be on the screen. After it's finished executing all of this stuff, we need to go ahead and make sure that the list is destroyed. So let's go ahead and add that in real quick. So we're going to go ahead and say if not is undefined, global.args, add its handle, which by the way, this should also be handle, not value, because we add the list to the map based off of the task handle, because that should be unique relatively. Each time that a task finishes, it actually gets its handle like removed, and so any task that has a handle, there should not be another one with the same handle. Alrighty, so if the handle is not undefined inside of our list, it should never be as long as you're using the wrapper. However, if you don't use the wrapper and you forget to add in your arguments manually, then the value will be undefined. So this is just like a little safety net. If you never ever call task init, then you do not need this probably. So then we're going to go ahead and make sure that it's actually a list. So global.args handle. If it does not equal no one, which is what it will default to, and if ds exists, once again global.args handle, and it's going to be a ds type list. Go ahead and make this a little bit bigger. We're going to go ahead and then destroy the list. Ds list destroy, just to make sure that there is no memory leak. Global.args question mark handle. Okay, and then we're going to delete the handle from the DS map. Okay, so we're going to say DS map delete global.args handle. So that will actually remove the handle from the DS map. Okay, then we would join the task. That's all you need for this. So let's go ahead and run this. Actually, don't go ahead and run this. I have a memory leak currently, which I will need to figure out. Or I guess I'll need to get rid of. Did I not create it? Oh, I forgot to say. I do this every time. Okay, so here we need to actually specify the data structure that we're adding it into. Also, while we're here, you'll notice I have this map and it's not being destroyed ever. So I'm going to go ahead and go into script. This is just going to be ser free args, I guess. I don't know, something like that. And so we're going to go ahead and say if ds exists, we're going to say global.args ds type map while it's not empty, while not ds map empty, global.args. We're going to delete all of the lists. And then we're going to also kill the task associated with it. So we're going to say var key is equal to ds map find first. So this will retrieve the first key, global.args. Okay, we're going to go ahead and retrieve the list associated with that key, ds map find value. Key. Oh, actually, sorry. It'll take in global.args, and then we'll take in the key that we found. If list does not equal no one, go ahead and destroy the list. Ds list destroy. If you use different types that you add to the map, then you're going to go ahead and say if list is equal to no one. And then in here, you're going to go ahead and say if list, or if ds exists, list, ds type list, go ahead and destroy it. Else, if like ds exists, list, ds type map, for example. That's not how you spell that. Type map. Then if you did this, it would be ds map destroy, list, so on and so forth. However, because for this one we're only using lists, the only one that we need to worry about is list. So if the ds exists, we're going to destroy the list, and then after that, oh, whatever, I guess I'm going to keep it there. Then after that, we're going to just go ahead and kill the task kill. And we're going to kill it based off of the key, which is actually the task handle. And then we're going to remove it from the map. So we don't have an infinite loop. This will make it so it will continue to go down and remove elements until there are 0 elements. .args key. Okay, and then at the very end, we're going to, after the map has been emptied, we're also going to destroy the map. Global.args And so we're going to use this either when this object is destroyed. So we're just going to go ahead and add in a destroy event and call that ser free args, or when the game ends. And the game end function, I believe, is called when you actually restart the game. So we can go ahead and say ser free args again here. So that's when this specific function is particularly useful. So now we can go ahead and run this and hope everything works. Alrighty, so you can see after 1 second, I called this function, or this script, and inside of the script it went through all of the values put into the list, which were just hello and world, and it printed them out to the debug console. Alrighty, so that's basically the end of this tutorial. This is an extremely powerful program. For the most part, personally, I do use this as a timer to call scripts after a certain amount of time. What makes this particularly potent is that you can have like 100 tasks running at once. And you don't have to keep track of them all yourself. Obviously the computer does it for you, and this will also free all of the tasks and get rid of all of the memory without you having to do anything. So if you need something along those lines, I would suggest doing this. Probably the biggest place that I've used this is inside of a networking system that waited 1 second, and if it did not receive an acknowledgement that a message was sent, if that message was important, it resent the message. So every single time I sent a message, I started a new task that waited 1 second and checked if it had been received by the other end or not. But of course there's many other uses. Inside of a recent game that I was just working on, I made it so all of a boss AI was based off of timers. It was actually like a state machine, but all of the state machine stuff, I don't know how to describe it. There's a lot of timers going on inside of it. Too many that using alarms would not be, you know, efficient. So I used this, and it worked out wonderfully. However, before I end off, I do want to put out a couple of words of warning. First off, you're going to be, all of the memory inside of the C++ program is going to be nude, so you have to be extremely careful when you're using this to not have any memory leaks. I believe I have everything, you know, leak proof. However, if you catch anything, go ahead and leave a comment so I can make adjustments and so other people can see. In addition to that, you know, it's a little bit hacky. Gamemaker was not meant to be a multi-threaded, well, I mean, it wasn't designed to be a multi-threaded program. So is using threading probably the safest thing to do? I would argue probably not. So do so at your own risk. However, it's also extremely powerful and extremely useful under many circumstances. So that is it for this tutorial. Next time I'm going to be doing almost essentially the same thing. However, I'm going to be doing it in C# instead. So for those of you who prefer C#, you'll be able to still follow along and get a similar result. Anyways, thank you guys for watching, and I'll see you next time.